No, that's all right. I've been talking. I can get water. Anybody want coffee? We have coffee. We have coffee, Keurig, if you want a Keurig. Coffee? After a while, our mattress shuts off, so you have to read. Isn't it cold? John, you want to make pound of Keurigs? Yeah. Regular coffee? So we have about 10 minutes yet on the run. You see those conductors coming down to the steel clad? There's silver wires coming down. All that is control units. It's of course shielded because of the RF. The black wires on this side, that's all the fiber optics that go from the PSM to the control module in here. Ties into this one, which is called the PSM, PCS. And that sends signals what voltage it wants. This is all controlled. Ventilation system, like I said, this is a water air. So the ventilation system feeds into here and it's all pressurized. Feeds into little channels, disperses it through, and then comes out right here. So in the wintertime, we don't have a lot of heating. It'll take care of itself. The water, it's actually 4 systems. This is a closed circuit system, which is distilled water. You see the funnel up there? I was just going to ask. Yeah, that's how you fill it. We usually take it off, but I'm at 64% right now, and we're close to around 80. You lose a little bit of water, just evaporation. So this is a closed system. The pump is on the back wall there, and then it has an exchanger, heat exchanger, where it pumps the hot water into the heat exchanger, and then the other side of it is cool water from the outside. And it's just blowing. It's not chilled with refrigerant, it's just air blowing through it. And that displaces it down to ambient temperature of outside. Then we have the test load that's in the back corner, of course. That's the big one, because you're taking 300,000 watts of power and dumping it into a little space. It's got to get rid of all that heat. So that's the bigger system that's back along the back wall. And that's also inside-outside, closed loop with heat exchangers. Yep. But like I said, under 73 degrees, it uses house air, and then when it goes across, and you'll actually feel the switch. There's a louver in the back, but the seal on the door is the one that is weaker than the louver. So the seal sits there and goes like this when you're here. So you go back and manually open it if it irritates you enough.
Green?
Have about 6 minutes.
No sugar, just green.
How much more minutes?
What's that, about 5 or 6? Just going underneath 7. So
What would hear to start roaring and come up?
What you're going to hear next coming up, like I said, what it's doing now is it's heating up this main tube, the 165. Then what you're going to hear is you're going to hear the air kick on. You're going to hear the air blast. There's an air blaster here that directs and channels air into certain ports, some of which blows right onto the tubes, right onto the hot spots, the coils. You're going to hear all that spool up, and then that will run red heating, which takes it up to 300 degrees. And then once that's done, then you're going to hear the switches go on, and it will be ready for it to go on. That goes to standby. And then when that takes place, then it's ready to go in the air.
So it's not in the air right now?
No, not yet. It's just warming up. Just like you have to do in the cold winter of Los Angeles. You warm your car up, right?
Get the ice out.
Yeah, you got to chip the ice off the windshield. But the reason it does it so slowly is you don't want that tube to expand and contract really fast. You want to preserve that tube. Now you will know, if we wouldn't have started it a little bit late, I have it on automatic right now. It's actually asking for standby. The flashing light is the next thing that's going to take place. Right here, I was talking about all the tuning motors. These are all your tuning variables. And under, now that I'm doing it, let me take this off. You can actually hear it. I'm going to tune this thing down to the 7200. Okay, now just listen real closely inside. Hear that? Hear everything inside is moving, turning, running the things down. Now it's tuned for 7200. That would be right to the test load. When we transmit, we're on 9275. So then I'm bringing it back to 9275. Now that used to take days. Yeah. With the old RCA, it would take days to tune. The BBC 250, that was faster. You could do that in a couple of hours by moving stubs and things. But and then when we have 11150, then that would be the program. The engineers will actually tune the set to the antenna at 11150, and then programs lock it in. So, like I said, we're on schedule. So it'll be programmed with 92. Right. 75. But right. When that goes off, what, 5 o'clock? Yeah, 6 o'clock in the evening. That's 5 o'clock in the evening.
You can shift itself over.
Yeah, and then, I'll go right to the scheduler. This is the schedule that I have. I have like 10 in there. It's really relevant. I have it up to the 17th. I have it up to the 26th, all scheduled in. And all this is it's just programmed at a start time, start date, start time, what mode of broadcast. I'm running next alarm. That's make sure you're really close to being on there. And then, so what modulation mode you want, and then when you want it to stop, what time you want it to stop, what antenna frequency you want to broadcast to is right here, which antenna, which frequency, because you can run multiple antennas through the switches. And then that's your frequency, and then that's your power. And like I said, it's all automatic. This does its thing when it's programmed correctly. When it's not programmed correctly, it waits. I logged in one night to the thermostat, like at 11 o'clock at night. I went to make sure that the AC, we had a little problem with the AC, was working. It was like 95 degrees. What in the world? I looked and it's still transmitting. It never went off. So they fixed it. It was a software glitch. So then you have event. This is what you don't want to see. All this stuff. The events aren't bad. This is what what the transmitter is doing. Everything that's done. If I push a button, it records it there. They can go back through it. Like I said, we can use the laptop or the phone, computer at work to log into it and see what it's doing. They can also troubleshoot from Switzerland, which is a lifesaver.
Wow.
He was able to go in and actually updated the software. Updated it last 2 weeks ago again. This is your safety. This is everything. It says systems safe for on. That means all your doors are locked. Everything's green, doing what it's supposed to do. Here's your cooling systems. You don't hear the motors running yet. We have 2 minutes. So that's why all the reds are here. We have the level and then the conductivity. Like I said, it has to be distilled water. If you have too many minerals in it, it'll pick that up and it will start isolating and calcifying the conductors and things like that. It's all stainless and copper, but still. And then temperature is in and out. Which was that? That's a ground. That means the grounding is off. That means you can get there.
Oh, you're right.
If you crawl in there. We actually adjusted the air. He wanted to direct it more onto the transformers were getting a little bit warm, so we wanted more air directed onto the bottom of the transformers so they would cool. And that was a rule. He said when you're putting that on, have all the electricity on, have it locked your head up, because it'll actually draw you in. There's so much power. So now these are the PSM. This runs off this bottom one, of course. 24 modules. You can run up to 4 failures before it starts giving you an error. So it's a redundant system. It uses what it wants to when it wants to. If your voice is a certain frequency and you would have that PSM tied to that frequency, you could burn it out. So what it does, it shifts it around to keep all the PSMs in use, keep them balanced. And right now we have a failure on 6. That's why it's highlighted, because I keep an eye on it. We have a spare one, but they're sending a spare over when they come. Another spare. He has to repair that, and he has to repair the one spare. We have spare modules for these two, the control system. That comes with the transmitter. So that's the PSM. That, of course, increases the power from 13.8 to 16.2 to 300,000 extended watts. Audio is pretty much all preset, because we do all the processing here. We don't do a lot of processing on board. Settings, that's more engineer stuff. Calibration and tuning. These are the different frequencies that are tuned in. You see 15150 is put in there, but it's not activated in the software yet. But he was working on trying to get it to come up, and it wouldn't do it. It's just too much reflective power. Of course, your user login, info is irrelevant, and schedule. Now what you're hearing, you just heard the pumps kick on. Those are the water pumps. And you're going to hear the air spooler coming up inside. And that's hear that coming up. You have a big blower fan in here that's feeding into the hot spots of the set. This doesn't take very long. This is a 2-minute. This is what, and the big thing with this doing now is it's taking that up to 300 degrees. It's called red heat. That's where it's, instead of heating it with the RF, which would be instant, nothing to inch. That's how the old one was. They actually bring the temperature up, preserves the life of that tube. We're about 3 minutes over time, so it's not not actually gonna hear the trumpet. Maybe I'm actually gonna take it off. Make it longer. Life is a little different because I have to make 5 hours of broadcast every day, 6 days a week. It usually takes me about 2.5 hours to process each block of broadcast. So, every day, I want to do one every day. We have 2,000 archived sermons, so I want to be able to do that. And also remember WMLKradio.com. You can get the stream, you can get the simulcast, plus you can go in there and put in the topic of the sermon. You can download it, listen to it online, and it's a really good site. Elder Meyer wanted to have a site like that as a simulcast. That's what the stream was started at, a simulcast for WMLK. That's how we always advertised it. You have the audio processors here. This is more for when they were setting it up, the waveform monitors, and clarity, how much sideband. Here's you can see the frequency test in the oscilloscope. You see that little sensor hanging down from the antenna? It's called the directional coupler. That's making sure that the signal going out is a clean signal. You don't have any side loads starting or anything like that. Now the next thing you're going to hear is a bang. It's not blowing up. It's just bringing the switches up. What that did, that brought the high power into the PSM bank. You see the PSM bank. Number 6 has an error. Shows up in red. It's not getting any input voltage. They don't know exactly why that one. He was doing it when it was here. They couldn't figure it out. 7 was causing a problem with 23. Also the day we were able to fix it and we did really well. It just gives you a warning back here on events. It's going to say that there's at least one defective module. And it goes, like I said, it's redundant up to 4. Now you can see the on is now on. Right now we're broadcasting what they call a carrier zone. signal out. What an inspirational tone that is. I love that.
Greetings, friends. We welcome you to the transmission of the International Shortwave Radio Station WMLK, broadcasting from Bethel, Pennsylvania, United States of America. Bethel, Pennsylvania is located...
Has anyone gone into their QBSTR? Elder Jonathan played it. But that's what the map of the world looks like. You have daylight, you have nighttime. So nighttime right now is just coming off of Africa. So we're broadcasting into the night, which is what you want to do on a lower frequency. On a higher frequency, like 15150, you want to broadcast into the daytime. It's a more daytime friendly frequency.
We invite your community.
So then when you zoom in, you can see all these places that have shortwave receivers. Okay, so
WMLK.
they took the one away. I used to always go into Quebec. But Prince Edward Island has a good one. When you click on it, it gives you the station. You click on his little station. So what it is, he has a box plugged into the network, internet, with an antenna on it. And then that actually is a receiver. Then you type in here your frequency you want to hear, 9275. And then down here is AM. I use AMN, which is a filtered AM. But then you can see right here is the waveform of the signal. This is off the coast of Canada. Then you can see that's the actual signal on his set in Canada that I can listen to in my phone. So it's instant quality control. You can adjust the set. And one thing that I really had trouble with, when you put on DSP, it's direct signal broadcasting. It's just, you're all the time 300,000 watts. The problem with that is when there's no modulation, like he's taking a breath, or it's a real low tone, you're still running a carrier signal. What they programmed in, I was able to figure out how to make it work, is the DCC, which is it's not a constant carrier. So when it's quiet, the set will actually reduce power. And then when Elder Meyer pushes his voice, so you hear the song like that, you'll see the power go up. You can actually see it on home. This is your forward power. Like right now we're only running 180,000 watts because it doesn't need it. But that's using a third of the power when you're running that way. So we're trying to see what the updated energy use is. Initially it was way high. You can see this forward power jumping around. But when Elder Meyer is preaching, boom, you can see that go right up to 300,000. So, remember what Elder Meyer always said, when you're in a congregation, sing out. Because your voice is going to go around the world if you're putting it in the congregation. And that's what we're doing. We usually lead with 4 songs, and then a broadcast, and a sermon, and a broadcast or a Bible study, or another sermon. If it's in a series, sometimes I like to run 2. And then music in between. You got to go to the bathroom. If you want people listening, you got to go to the bathroom. So, okay, and then our engineer added the power lights, which are 3 phases. The step start is up back there on top. That is feeding each individual leg. That was one of the delays that we had. But praise God, we were able to get it right. All right, anything else? It's on the air. Praise Yahweh. Everybody's just yeah, it's wonderful. Johnny, we went out to the bus. Okay, well, that's the set. Yeah. Well, thank you all for diligently supporting the Assemblies of Yahweh. I didn't want to learn it. I didn't want to learn it, but